Next up on stage, we have Michelle Pelletier, a master's student from Department of Civil Engineering under the supervision of Professor Stephanie K. Loeb, and she'll be presenting on unlocking the spectrum using fluorescence to assess water safety.
Every year, 170 million people get sick and they don't know why. 120 million of them get gastrointestinal illnesses, and 50 million of them get severe respiratory illnesses. What's the problem? What's causing this? Swimming, canoeing, and fishing. Every time you do an activity in or near water and you run the risk of ingesting some, you might get really, really sick. A viral dose can be contained, this comes from human fecal pollution, and a viral dose can be contained in one single droplet of water. However, children consume up to a cup of water for every hour they're playing in the water. Right now, they test your water by looking at fecal indicator bacteria. It takes between 24 hours and up to 3 weeks to find out if your sample is safe or not. So the water that you're bathing in right now was safe yesterday. That makes no sense. So, meet beam spectroscopy. This is a better way of doing things. FEAM, or fluorescence excitation emission matrix, stands for looks into the glowing components in a sample by shooting beams of electrons at it. All right, we get the excitation and emission wavelengths as well as the fluorescent peaks. The more a sample fluoresces, the more it is filled with the components that we're looking for. So I'll be looking mostly at ring-like structures, more precisely tryptophan. Tryptophan is an amino acid. It's found in proteins. These proteins are found in poop. And they glow, and they've been very widely studied. We can see here a deconstructed FEAM plot. So we know a lot about them, but we haven't used them yet. What I propose is the use of fluorescence to make a fingerprint of your water samples. Firstly, I'll be taking influent from wastewater treatment plants and testing it with classic biomarking techniques. Afterwards, I'll be taking those same samples, putting them in the FEAM, and getting a fluorescence intensity report. Afterwards, I'll be correlating these two by pushing it into AI, namely by doing exploratory statistical analysis to create a viral quality monitor. And the end goal of this is to give this product to recreational water managers so that they can ensure a continuous and good monitoring event. So if you can't translate your data into policy-relevant outcomes, what's the point? Beyond checking if your beach water is safe by using FEAM, which is quick, reliable, and cheap, you can apply this to humanitarian crisis situations and to water insecure regions. Thank you very much.